So guys, let me show you a very special cases. Actually, there are only two cases in which they are so special. Actually, we have many, let's call them special cases. For example, when you have a pipe of same height, well, then you have no height values. Same diameter, you have same velocity. You have no pump and no outlet. So actually, you can calculate the change in pressure with respect of the friction. And what else? We have also examples on how much pump do we require. We just solve for WP and add all the values to the right. So we change all this right. We pass it to the right, and this will be the total load on the pump. So we have many cases. Let me erase that. And one important case I want to show you is the Bernoulli equation. The Bernoulli equation adding friction, and the Bernoulli equation using pump. This is actually just a special case of this equation, and more interesting yet is the Torricelli's law. It comes again from this equation. So instead of learning by heart every case, you just need to learn this case, this equation, and know what to take out. For example, Bernoulli's equation is this equation right here and right here. As you can see, it has no pump, the system, no outlet, has no friction, so we are left with pressure, height, velocity. In this case, they are dividing by gravity, as I told you in the last videos. So just make sure you take gravity, you divide this equation by gravity, and you are done. You have your famous Bernoulli equation. Now, Torricelli's law is another yet interesting. We have A and we have, let's say, V. So if I wanted to calculate the velocity of V, how would you do that? You could either go on internet to check out the Torricelli's law with respect of these tanks, or we can use this mechanical equation. Since we have here atmospheric and atmospheric, we have no change in pressures, we have no pump, we have no turbines. What else? We could ignore the loss on friction. So we are left with, well, since the velocity on here, the starting point is 0, we can also ignore it. So we are left with only 3 right here. And actually I could arrange this right here, so I got G times C A minus CB. And don't worry guys, we are of course going to, well, erase this. We're going to see this later with examples and of course more logically, but I just want to show you guys that you don't need to learn by heart all these equations of V, and solving for V will be, hopefully it rings bells to you, 2 times the gravity times the height. The height is essentially CA minus CB, and take out the square root and you got your velocity. You want to check more problems, go. We're going to show you more problems of this type, no worries. But I just want to once again to tell you that you don't need to learn by heart these equations. This is Torricelli's law. But it comes from knowing that since they're same pressure here and here, the velocity on A is almost 0, there's no pumping, there's no turbines, we can ignore friction loss, you get that value. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, and then you have the sections. If you're, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.